A coordinate plane is the intersection of a vertical number line and a horizontal number line. You'll see on your screen that we have a horizontal number line, which is called our x-axis. Then we have a vertical number line, which is called our y-axis. These two number lines intersect right here at this point in the middle, and this point is where the x and the y values are both 0. This is called the origin. We can graph ordered pairs on a coordinate plane, and when we graph ordered pairs, we need to know that they are always written in the form x, y. If I look on my coordinate plane, I can see that it is split into 4 quadrants. This first quadrant is the quadrant that we are used to using. In this quadrant, you'll see that the values on my x-axis are positive, and the values on my y-axis are also positive. That means that any ordered pair that is graphed in quadrant 1 will have a positive x value and a positive y value. Now, if we move counterclockwise to quadrant 2, you'll notice that our x value now consists of negative numbers. Our y value is shared with quadrant 1, so our y-axis here has all positive values. Any point that is plotted in quadrant 2 will have a negative x value and a positive y value. Quadrant 3 is located below quadrant 2, and you'll notice that it still has negative x values, and this time the y values for quadrant 3 are all negative as well. So any number that is plotted in quadrant 3 will have an ordered pair with a negative x value and a negative y value. Quadrant 4 now has an x-axis that contains positive numbers and a y-axis that still contains negative numbers. Any number or ordered pair plotted in quadrant 4 will have a positive x value and a negative y value. When we are plotting an ordered pair, we always start at the origin, and then we use the x value, which is the first value in your ordered pair, to move either left or right. From there, we move up or down to the appropriate y value, and then we place a point. So let's practice with these points. A has the ordered pair 3, 5. I remember that an ordered pair is always in the form x, y. So that means our x value here is positive 3, and our y value is positive 5. Whenever I plot a point, I always start at the origin. And since my x value is positive 3, I'm going to move 3 units to the right on my x-axis. So I'll move 3 units right. And then since my y value is positive 5, that means I'm going to move up 5 units on my y-axis. And then I'm going to place a point and label it as A. Point B has an x value of negative 2 and a y value of positive 1. I'm going to start at the origin, and the first thing I'm going to do is move to negative 2 on my x-axis. Remember, my x-axis is my horizontal axis, so to move to negative 2, I will move 2 units left, and then I'm going to move 1 on my y-axis. Because it's positive 1, I'm going to move 1 unit up, and this will be my point for B. Point C has an x value of positive 4 and a y value of negative 3. So from the origin, I would move right 4 units to find positive 4 on my x-axis. Then I would move down 3 units to get to negative 3 on my y-axis. Point D has an ordered pair of negative 2, negative 2. So if I start at my origin, I would move to negative 2 on my x-axis, which is 2 units left. Then I would move to negative 2 on my y-axis, which is 2 units down. The coordinates for point E are 6, 0. If I start at 0, my origin, I am going to move to positive 6 on my x-axis, so I will move 6 units right. Then my y value is 0, which means I don't need to move up or down, and instead I can place my point right here where x is 6. Point F has an x value of 0 and a y value of -5. Since my x value is 0 and I'm starting at the origin, that tells me that I'm not going to move left or right and instead should stay here. The -5 for my y value tells me to now move down 5 units. So point F is going to be located right here on my y-axis. We can also use coordinate planes to plot figures. We can use those figures to solve problems like perimeter and area. You see that you are given the coordinates for J, K, L, and M, and it tells us that it's going to create a rectangle. We are going to use that rectangle to find the perimeter and area. The first thing we need to do is plot our points on the coordinate plane. So we'll start with point J. Point J has an ordered pair of -4, 3. That means that if we start at 0, we're going to move to the x value of -4, which means we will move left 4 units, and then a y value of +3, which means we will move up 3 units. And I'm going to place my point here and label it as point J. Point K has an ordered pair of -4, -2. That means that I would start at my origin and I would move left to -4 on my x-axis, and then I would move down to -2 on my y-axis. And I'm going to label this as point K. Point L has an x-axis, an x value of 1 and a y value of 3. So from the origin, I would move right to 1 on my x-axis. Then I would move up 3 units to 3 on my y-axis, and I'm going to label this as point L. Point M has an x value of 1 and a y value of -2, so to get to that, I'm going to move right 1 on my x-axis, then I'm going to move down 2 on my y-axis, and I'm going to place a point here. Now, you should notice that if I were to connect these points, I am creating a rectangle on my coordinate plane. I can use this rectangle and I can find the perimeter and the area of the rectangle. To do this, I need to know all of the side lengths. So I can use this and I can count to find how far J is from L. If I start at J, I notice that I'm going to move 1, 2, 3, 4, 5 units to get to L. So the length from J to L is 5. We know that since the length from J to L is 5, the length from K to M is also 5. Now we need to find the length from L to M. To get from L to M, I would move down 1, 2, 3, 4, 5 units. So this length is also 5, which means that JK is also 5 as well. So this is a special rectangle that is also a square. To find the perimeter, I know that I would add the side lengths for the whole figure. So I would add 5 plus 5 plus 5 plus 5, and that would give me a perimeter of 20 units. To find the area of my figure, I know that I would multiply length times width. So in this case, I would multiply 5 times 5, which would give me an area of 25 square units.